let's start with the main question. What is the Storage.AI?
Ooh, I'm so glad you asked that question.
Go for it, Jay.
One of the things that we've been trying to solve as far as an industry is concerned is when we start to get into these systems of AI, HPC, the really big systems that up until very recently have been sort of this big mystery. We started realizing that in order to get data into the actual workload itself, it's been something of a challenge. One of the things that we've been working on is a relationship with some of our partners inside of the industry, like Ultra Ethernet, for instance, where the data is not indigenous to the network, right? So if you've got a bunch of GPUs that are doing work in AI, there's no way to easily get the data in and out of those GPUs over the course of the life cycle of a workload, which is actually multiple workloads put together, you have different types of data needs. It's not all the same all the time. Sometimes you've got very long sustained reads, sustained writes. Sometimes you have bursty. Sometimes you have random. Sometimes you have sequential, and so on and so forth. And so having a one-size-fits-all solution actually introduces a lot of inefficiencies into the system. So if you've got really expensive GPUs that are sitting idle waiting for the data to become into their memory buffers, that's a lot of money that you're spending doing nothing. And so one of the things that has become very obvious is that we need better, more efficient ways of getting data into the storage workload. And so we've got a series of solutions that are being thematically combined inside of SNIA to solve this very problem. And fortunately, we have a lot of different people and companies that agree that this is a problem that needs to be solved and should be done by storage experts. And that's why we're doing what we're doing.
So, what is actually involved with these standards? Are you coming up with new ones? Are you using existing ones? SNIA actually, has a number of things that it's involved with. How does this all work together?
Yes. So what we've gotten a lot of work already done over the last several years that in and of themselves have very good and unique applications. But they also have applications for this type of workload. And so what we've been able to do is say, hey, look, I have a memory data mover. We call it SDXI, or the Smart Data Accelerator Interface. And basically what it does is it allows us to move data from one memory register to another memory register. This is just one example.
Hmm.
It's designed specifically for virtualized environments where you effectively can take one container or one virtualized host and then be able to move data using the hardware into another memory register. However, it also has pretty interesting applications for AI, where you need to mutate the data or transform the data into something that the GPUs can actually use, because the data is not necessarily native to what the GPUs use to process. So that's one example of how we have existing projects that have applicability inside of the AI workload. Then we have some new projects that we want to work on, for instance. So in layman speak, if you've got a GPU and you need to access the data, you don't get to access the data directly. You have
Hmm.
to go through God's seven kingdoms in order to be able to get the data into the GPU memory buffers. And unfortunately, there's a lot of room for error, right? A lot of things that can go wrong, which is why we build in a lot of checkpointing inside of the native AI workload to make sure that when these things go wrong, we can roll back. If we can simplify the process of getting data in and out of a GPU or a TPU, and we can also simplify the process of a GPU requesting information, initializing that IO, and we can be able to do this both locally and on our storage as well as remotely on our storage using same semantics, then we've solved a lot of problems by just bypassing, those kinds of, wonky things that we have to do to get the data inside of the GPUs. And so we've got a combination of things that we're doing new, particularly when it comes to the processors. And we've got some things that we have already been working on that allow us to leverage, the standing on the shoulders of giants. So it's a combination of the two.
Well, given that you have all these other standards, why do we need storage AI? What's it going to be bringing to the table? And is it going to make the job of the designers and developers easier?
Well, if you think about it from that perspective, one thing that SNIA has done very well over the course of its lifetime as an education tool, right? So a lot of organizations, including SNIA, develop standards, develop specs, create content for developers to utilize. But a lot of that work around what you can then do with it comes back to SNIA for an educational point of view. So we've got all kinds of things we do, webinars, we do trainings, we do all this kind of stuff. We hold events. And that's one reason why Storage.AI, with this overarching look from SNIA, in combination with all of the other work groups that we're targeting to play with nice, right? Is something of value. Because to your point, in order for this to add value to the ecosystem, people have to understand what it is and how to use it. And we all tend to spend time in our little bubbles developing all our cool little tools. And at some point, they've got to coalesce into something that can either hook together nicely or at least be, combined in such a way that it adds value to the ecosystem. So to your point about, developers and how does this help? One of the key aspects of this is once the technical work is started or done, like we've got stuff already in place within SNIA, we've got stuff within all the other working groups, bringing it all together and then saying, hey, here's how you can actually take advantage of it. And that's part of why we're really excited that, kind of SNIA is taking the lead to say, hey guys, we love what everybody's doing, but we got to put it all together somewhere.
Yeah, and so to add on to what Scott said, what I would say is that's exactly it. So we need to be able to take all these pieces using Jay's example of SDXI. Great, work's been done on that for a while now, and there's a 1.0 spec that's out. Wonderful. How do we apply that to AI type workloads as Jay described? How do we then blend that with other technologies that hadn't necessarily been considered at the time that the SDXI spec was developed, and use them to build up this overarching solution in a complete package?
I was looking at some of the diagrams that you've been putting out. The architecture just on the storage side, the communication side, looks to be rather complex. Is that something that's going to be required for all applications, or is this more of a standard way that the cloud computing is working these days?
Well, there's a lot to unpack in what you just asked. So let me try to see if I can paint a picture with words. So what we do in these systems is we effectively fragment out the different networking types, right? But it's all based upon the need for data at a specific point in time and the reduction of contention for that data. So what we do is we have in the graphic that you've probably seen, we have a picture of a server node, and that server node has GPUs, it's got CPUs, and it's got NICs. So the process of having the GPUs talk to each other involves how we have the relationship between the memory situations in those GPUs. If we want to do a shared memory situation where all the GPUs share one large memory buffer, that's called scale up networking. Okay. That basically means we've got a bunch of GPUs acting together like one big, huge honking GPU. And then we want to connect these big, huge honking GPUs together because the roles are played in such a way that the workload has to be sharded across and parallelized amongst different GPUs and the roles that they play. That's called scale out networking. None of that has the data indigenous to the network. All of it is external. All of it is out somewhere else. And there's a couple of different ways that you can access that data. You can access it through file, block, object, but each and every vendor, every company, every solution has a bespoke, tailored way of doing this, which does not translate over time. For instance, let's say I build a $1 billion data center, right? Just to make nice, low numbers here. I built $1 billion data center, and by the time I run through my workload, which could go for months, it can even go for a year or more, just one workload can take an awful long period of time. Well, by the time that I want to, upgrade that system, I can't necessarily do that because the data structure is different based upon the processors that are going to be coming in next. So I can't checkpoint out, take out the processors underneath and put in new ones and then expect to be able to use the same results that I got because the numbers don't match. The precision points don't match. If you're talking about FP4, FP8, FP32, whatever it winds up being, the data structure itself changes depending upon the processor types. It also depends on what the storage types are, what happens with the data structures on the actual capacity side. All of those things have to align, and they're all specific to a particular vendor. If I want to bring that stuff in to the networks that will use the data natively, I have to have coordination across the board from just both the processor vendors as well as the storage vendors, as well as the networking vendors. All of these things have to align. The stars have to align really, really tight margins of error, right? And that's why it's really important that we start to think about those problems both inside of a server as well as how they're all related out, interconnected. And there are a lot of moving parts to that end.
Yeah, well, speaking of moving parts, obviously things like solid state drives are major piece. Technologies like NVMe and RDMA are all part of the puzzle. How do these things work with respect to, some of the hardware like the SSDs? And how are they, people going to be taking advantage of it in ways that may be different than they're doing now?
Well, this is an
Okay.
interesting one, and kind of playing off of all of the stuff that Jay just talked about, right? So
Mhm.
I love geeking out on all kinds of things, but I also like to sometimes bring it back a little bit. And I'm going to reference one of my all-time favorite sci-fi shows, Star Trek, right? You got the universal translator. That's what Storage.AI is for people that understand that and know what that is. No matter what language I'm talking, that thing that we're calling Storage.AI is going to be able to bring those all together. And when you talk about NVMe and solid state drives, this is where things like the STXI working group, the computational storage working group, NVMe and their computational programs implementation of the computational storage architecture from SNIA come together. And then you throw in things like wanting to go to native Ethernet type interfaces instead of an NVMe or a SATA or a SAS, right? We have all of these architectures still exist. If you think about the traditional, what people are calling traditional, which I would call the legacy hardware of hard disk drives, they're SATA SAS. And you've
Mhm.
got to be able to talk those too. And all of it has something to do with, to Jay's point, getting the data from a box over some kind of pipe to some kind of processor. And there's so much layering capabilities there that are today being brute forced. I mean, we'll be honest, the AI revolution, evolution, whatever you want to call it, has been so aggressive at just throwing things at it. People haven't gone to the point of fixing that problem. And so one of my favorite ways to represent that is the lovely hype cycle. We're sitting here growing, 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 and we hit the top and we're like, oh crap, now we've got to make things work better. And we drop down to the bottom of nowhere, and then we have to come back around and get it plateaued. And that's what we're focused on with this, is getting all of those architectures that are continually evolving themselves to work together as we evolve the overall ecosystem. So it is a challenge. It is interesting, and it's a lot of fun to do that. And one of the beautiful things about what we're doing with SNIA is we do this across so many different companies. We don't have just the SSD vendors. We have the hard drive vendors. We have the networking vendors. We have the GPU, CPU vendors, all talking together in a collaborative way that is allowing this to happen, but still allow each of those companies to do something that generates them individualized revenue, right? So we do have to realize that at the end of the day, somebody's got to make money on all this.
Well, it sounds like, making all these connections is going to be a definite plus. Um, One of the things when you have this many things involved is that is not always talked about is something like security. Um, how does that come into play with all the discussion with respect to storage AI and all of the SNIA standards, for example?
Wow, boy, did you just open up Pandora's box. So we have the security is one of those going down the labyrinth, you know, and here there be monsters, right? So we are working with a number of different organizations, including IEEE and similar type of veins with different government regulatory bodies to figure out how to answer that problem. It's a moving target. And
Mhm.
so we have a couple of projects already in flight for security in general, for security for data, but have specific AI applications. And that is still somewhat of a player to be named later, but the work that we've been doing and working with other organizations is well underway. And so it when I was putting together the list of projects, I deliberately left security off because it is such um, an involved conversation because it involves things like, ever-changing regulatory policies, the things that are going on both the United States and in Asia and in Europe, really are going to affect what's happening, and that needs to be a theme throughout the entire process. So we're working not only internally with our security experts, but also with other organizations that are heavily oriented on the security, both in terms of data at rest as well as data in flight.
And I'll add on to what Jay had to say there, and that is that SNIA does have a security group with members who are focused on security, and those same contributing members are members of all these other organizations that Jay mentioned. They're very versed in what's going on in IEEE or TCG or you name it. And so those, luckily for SNIA, those experts are here and they are able to contribute across the stack of everything that Storage.AI is going to be involved in, and the security needs that need to be addressed in each of those components.
Now, obviously, Storage.AI is just in its infancy at this point, but where can we see, the fruits initially? Is there a specific area that you're going to be tying together or introducing people to?
So I think one of the things that this is going to be one of those multifaceted approaches to addressing this, because there's so much stuff that's going on that's going to take a lot of education, because quite frankly, most people don't know how AI workloads work in the first place.
Mm-hmm.
So just simply going off and rattling off these initiatives and these technical work groups and these standards won't have any meaning. It'll be names on a page. So the first thing that we need to do is identify what the data requirements are for different stages along the workloads. So for instance, now individual vendors like Scott and Jason's companies have done a really good job of outlining that this type of process needs this type of data at this type of point in time, because we look at an AI workload as something of an opaque box. But when we do tend to break it down, we kind of look at it from the endpoints and we see all the stuff that happens throughout the course of the life cycle. But when you break it apart horizontally, we have the ingesting of the data, we've got the pre-modeling of the data, we've got the forward and backward passes, which requires the sharding, and there's a whole bunch of networking applications. Then we've got the checkpointing and the archiving, and that's just the training. It doesn't count for the inferencing or the RAG elements. Every single one of these has a different type of storage touch point. As we go through and educate people on what type of data you need, when and where, I believe we'll be able to say, oh, and this is why this particular point of SNIA's initiative is important and how it applies. Right. So some of them are very, very small areas. Some of them is like individual memory buffers. Right. We've got stuff for that. And then something has to do with how do you program a non-volatile memory device. That's another individual thing. But taking in the aggregate, it's not just a matter of saying, oh, we've got this little pinpoint of touch points, but no, it doesn't solve all of the problems, but it's not supposed to. You have to be able to see holistically how each of these different things work together in concert. And so we have to give people the understanding and the education of what a concert looks like. What are the instruments of that orchestra that are going to be playing, and not just tuning up into a different, to different notes. I'll mix more metaphors into that, I promise.
Mm-hmm.
But I think where we are right now is that we've got a lot of people who intuit that there is work to be done, but they're not really sure where to start because they don't know the right questions to ask. So the first stage is to give them the ability to ask the questions in a place where they can feel comfortable being able to understand, where the other side of the equation is. If I've got processor people who don't understand networks. I've got networking people who don't understand storage data. They don't understand storage at flight and flight. They don't understand storage at rest. And then we have the security people who are really concerned about locking everything down. And so putting them all in the same place, putting them all in the same room and saying, when you say this word, it means this over here. Right. So we have to come up, we have to use the Star Trek Universal Translator approach to solving those problems. Once we are able to do that, we can kind of tie in the work that we're doing, make people understand where the gaps are and where we need to work on. And I can guarantee you that once I start bringing in the processor people who really only know about what's going on inside of the memory buffers to be able to process it, then we're going to be able to get some real good work done, because it's not just I do the hard work and you just have to do what I tell you to do. And that's one of the things we have to get over and get through.
Storage.AI is obviously targeted at the large cloud providers, people like Amazon, Facebook, and Meta at this point. But is it something that essentially scales down to private uh, data centers or even large embedded applications?
The short answer is yes, right? This is one of those things where the rising tide does lift all boats.
Hmm.
because because what you're really talking about here is removing inefficiencies in a system regardless of how big it is. And to that end, the workloads themselves all have the same basic components. They have the same roles, right? You've got a processing role, you have a memory data movement role, you have a networking role, you have a storage capacity role, you have a storage and flight role, right?
Hmm.
No matter how big or how small the systems is. If you can create efficiencies along the way that people can use, it doesn't really matter what the form factor is or what the deployment size is, right? The important thing here is that it's not an all or nothing kind of a thing. If I can use better data, like I said, the SDXI, a really good example, right? SDXI was designed specifically for enterprises, right?
Hmm.
So it also happens to be good for AI type of workloads. So that's an instance of the other way around, right? We're taking something that was designed for virtualized or containerized environments and saying, hey, you know what? This also works really, really well for data transformation. So there's a two-way street here. Um, what I want to encourage people to do is come up with those kinds of scenarios and use cases and say, hey, look, I think that the work that you're doing here could be applied here. Can we have a conversation about making it more robust for these types of non-hyperscaler workloads? That is exactly what I want as a chair of the organization. I want people to come in and say, you know what? I think what you're doing here may have value for what I need. Let me have this conversation and see who else agrees with me, because that's the whole purpose of doing this in an open forum.
Okay, well, SNIA is actually, a very large organization and you have a lot of people involved, but what happens if somebody is interested in doing more, contributing more, for this particular project? How do they get involved?
We do have a landing page for it. It's actually pretty simple to get to SNIA.ai. It's fewer letters to type, so we thought it would be easier to have that. And it lands on the storage initiative, Storage.AI, tells you about the current work groups, the current alliances, the founding members, and then, of course, if you would like to participate with so many member companies already, you may already be a member of SNIA and not know it, but if you're not, easy membership opportunity to join. SNIA recently re-architected the membership engagement model so that we can make it easier for more participants to be able to jump in and add value, because we see that, what we've evolved over the last, half decade, if you will, last 5 years and last 20 years of the organization. So lots are going on, and that's probably the fastest way to find us.
Where do we go from here? What can we anticipate in looking at your crystal ball for the next year? And, is there a long-term target?
Yes. So, so okay. So the phases that we're looking to approach, they're not official phases, but
Mm.
but there's an iteration that we're going through right now, right? So as you pointed out earlier, we're very embryonic in this. We've got a lot of people who have really good ideas. We got a lot of interest and motivation for having people come together and work. Everyone from, the smallest startups to the biggest hyperscalers are involved in this, and what makes us very happy to see that kind of level of enthusiasm on this. So many of the companies are still just getting their feet wet when it comes to the new participation model, the new communities inside of SNIA. And so there's a little bit of a process education that we have to do at the the SNIA Developer Conference in September.
Mhm.
We will be going over a lot of the brainstorming about what we want to work on first. What are some of the ideas that people have that they want to introduce that maybe we haven't thought of yet? And then we're going to start running the regular meetings that are going to be, absolutely critical for these kinds of consensus. And then the individual technical working groups will be able to determine, what kind of timeline they can start working on these different things, whether we need new types of working groups and so on. And then over the course of the next year or so, we're going to have some face-to-face meetings where we're going to could buckle down and do some whiteboarding and try to figure that out. And then we're going to work with other organizations. I mentioned UEC before. We've got some other relationships like with OCP that are finishing up, and we're going to be working with them to create some data scenarios that are going to be applicable for what they do, and basically broaden the reach and the scope of what we're looking to do from a ecosystem perspective. And that's what my plan is for the next year.
Sounds good. So in closing, Jason, Scott, do you have any other comments that you'd like to make before we wrap up?
I think that this is a really exciting opportunity for everyone in the industry and SNIA in general. There's a lot of work to be done in this area, and to try to bring all the pieces together, as we've discussed, Scott and Jay have mentioned as well. And I think that it's an important time to get involved if you're not already.
Yeah, and as far as following up, additionally, we have several events throughout the year related to our SNIA Developer Conference, whether it be the big one we do every year in September or the one we do in the springtime. And those will always be available online for review. And we do lots of great communication of all the work that's being done, both within and collaboratively in the environment. So encourage folks to just continue to follow along and participate.
Excellent. Well, thanks very much for filling everybody in. I look forward to talking to you guys again, probably in about 6 months or so, to see how things have progressed.